Going forward, we will just look at such schematics just to re-emphasize the concepts. Here we are looking at going up from agriculture, health, trade, policy. So food availability, quality, quantity, nutrition, utilization, trade, food stability of availability, and so on are all important factors. Good governance, human rights, gender equalities, infrastructure, risk mitigation, social security, legal framework, and so on are all part of the food industry and climate change. Also education and awareness and care, for example, breastfeeding, and of course food availability, which depends on production and trade, and access to food, which depends on income and infrastructure. Health services, environment and hygiene. So this one is global to national, this one is subnational, and this one is at individual level. So food intake or food utilization, how the body can use the nutrition from the food, which also depends on water quality and food quality, for example, as well as individuals' abilities and physical condition, health status. So that's food utilization again. So this is ingestion, this is the body's absorption. So together they determine food and nutrition security, adequate nutritional status, which then affects care and breastfeeding, which feeds back to the growth of the child and survival and health. So you can see these strong links between them. So thinking again in terms of food and nutrition security, we can go from staple supply, risk reduction measures, and environmental sustainability, which are all we have to think about for mitigating and adapting to climate as well anyways. So food again depends on availability, access, and use and utilization. Here we have crop production, efficient water use, stocks, and trade. So this again is consistent with what we mean by planetary health. Access depends on income, prices, markets, transfer, infrastructure, food distribution within households, and gender issues. So girl child, will she get the same as the boy child, for example, and so on. Food and nutrition knowledge, food preparation and nutrition behavior, cultural traditions, knowledge standards, health status, hygiene and care opportunities. For example, poverty often leads to calories versus nutrition, and that can end up leading to obesity and other problems. And people may think a person is obese because he's eating too much, but it could be that calories are being substituted for nutrition in the case of poverty-driven food-seeking behaviors. So together again they determine food and nutrition security. Okay, so throughout these, climate is affecting all of them, right? Climate affects availability, access, use, and utilization, and hence also affects food and nutrition security. We already seen this before. High carbon dioxide is already known to be cutting crop nutrients. Here we're looking at wheat, rice, maize, and soybean. Before we only looked at protein, but here we are looking at percentage under CO2 levels expected in 2050. Depends on the scenario, but ignoring that detail, we will see that zinc, iron, and protein are all reduced in all of them, in wheat, rice, maize, and soybean. Again, soybean remains more robust, especially in terms of nutrient content, protein content compared to wheat, rice, and maize. Okay, what is happening to fisheries? Warming oceans, acidifying oceans are reshaping fisheries. Of course, there is overexploitation of all the fisheries also. So this is looking at marine species gradually moving away from the equator into cooler waters to get away from warming, and as a result species from warmer waters are replacing those traditionally caught in many fisheries worldwide. Scientific studies show that this change is related to increasing ocean temperatures. So we are looking here at tropics and subtropic and temperate oceans. Those are the regions here shown in terms of gradient of colors, so warm colors and warmer to colder colors from 1970 to 2006. as open temperatures were rising, catch composition in the subtropic and temperate areas slowly changed to include more warm water species and fewer cool water species. So here we are going from temperate and cool water fish to subtropical fish to tropical or warm water fish. 1970, many more temperate cool fishes with few subtropical fishes. By 2000, the fraction of temperate cool water fishes dropped, and there was an increase in tropical and subtropical fish. And in the future, we expect the cold water fish to have basically disappeared in the subtropic and temperate oceans, whereas in the tropical oceans, the combination of subtropical and tropical warm water fishes have dropped and are expected to be greatly negatively affected in the future. These shifts could have negative effects, including loss of traditional fisheries, decreases in profits and jobs, conflicts over new fisheries that emerge because of distribution shifts, food security concerns, and of course a large decrease in catch in the tropics. Okay, there are already massive heat waves in the tropics as well as in the Gulf of Alaska, for example, and the July 2021 heat wave is supposed to have killed maybe 1 billion fish up there in the northwestern Pacific Ocean, northeastern Pacific Ocean of northwestern US and Canada. A disaster that is happening right in front of our eyes. Aquaculture has lots of issues in terms of pollution of water, oxygen losses, sea lice, and so on and so forth. But to put a positive spin on it, Nature Conservancy looks at aquaculture as a way to mitigate pollution, provide habitats, support fish populations, and reduce climate change, local climate change impacts. So you can see that the three-dimensional nature of the water column can be exploited by doing sustainable aquaculture, and those are the aquaculture regions with the neighborhood benefiting from these practices as well by combining shellfish farming in this way. These are already in practice, implemented, shown to be sustainable and beneficial. Other crabs and so on that are being farmed here, and of course seaweed farming, and they also have many applications, including some oils. Some seaweed can be used for bioenergy, some seaweed can be fed to cattle to reduce methane emissions, and so on and so forth. So for example, shellfish and seaweed aquaculture gear provides refuge for macrofauna, including fish, crustaceans, and other invertebrates. Okay, seaweed aquaculture can reduce carbon dioxide and oxygenate waterways, and thereby locally mitigate the effects of ocean acidification. Through increased water clarity, shellfish aquaculture may promote the growth of eelgrass seabeds and a carbon sink. Okay, and these are not susceptible to wildfires, and some of these aquatic forests can sequester 3 to 10 times or more carbon than terrestrial forests, which are susceptible to wildfires, of course. This is just another schematic of smart growth in aquaculture, seaweed farming, pen farming in fast currents and deep waters, and offshore cages, minimizing impacts on seafloor and fishing communities. Okay, so some areas are not optimal for aquaculture operations, and some are aquaculture development zones. So you can see these. I won't go into these details because the idea is to look at population growth, climate change impacts on these habitats on land and ocean, on food production, on fisheries and aquaculture. And we'll come back to some methods on land agriculture, terrestrial food production, and I'm just showing here some proposed methods for smart growth in aquaculture and using aquaculture for these benefits here in terms of mitigating pollution, provisioning habitats, supporting fish populations, and reducing local climate change impacts. Okay, so we will leave this here and come to additional points of the interactions between climate and food production systems, food security, nutrition, and food safety.